Okay, in this section we're going to be looking at solving binomial probability distribution problems using the distribution table. That's on table A.1 on page 583 of your book, so you need to be able to pull up that table and look at it while we work through this problem. Now, in this particular problem, we're going to assume that random guesses are made for 5 multiple choice questions on an ACT test. The answer choices of A, B, C, D, and E. So we need to start off by specifying what is our N, and also we need to specify out what we're solving for. So here we're looking for the probability of a correct answer for a question. So when we're looking at this, our N is going to be equal to 5. We have 5, so there's assuming that there are random guesses made for 5 multiple choice questions, right? And so when we're looking at this, the probability of getting a correct answer for any one question is going to be 1 divided by 5, so it's going to be 0.20. So that would be our small p. Now, the next thing we're going to ask here is to find the probability that the number x of correct answers is exactly 3. So here we're solving for x is equal to 3, so we're asking what is the probability that I get exactly 3 answers correct. Now, to solve this problem, and you go look at your table, you're going to find the probability for the number x of correct answers is exactly 3. Here's what we're solving for. So we start off with n equals 5. So you go down your left-hand side here under n until you get to the 5. And notice I've blocked this section off in purple. So once we've designated that section for our n, the next thing we're going to do is we're going to look at the subsection x equals 3. So this is the subsection to the right of our particular n column. And here I've designated all of that in red. And then we're going to go across to the right until we reach the column that corresponds with our specified probability that we've already calculated, which is 2.0. So once we have that, look where they overlap, and the corresponding number of 0.051 is the answer to our question. So find the probability that I will have exactly 3 correct answers out of these 5 is 0.051 if I am simply guessing. Now, we've looked at probably for exactly 3. Now we want to look at the probability that the number of correct answers is at least 3. So if we're solving for at least 3, what are all the possible amounts of correct answers that meet this criteria? Pause the video here for a moment and write this out, and then turn the video back on and we'll check it together. Alright, at least 3 means the number of correct answers could be 3, 4, or 5. Remember, if I've got 5 correct, that means I also got 3. So, remember we're looking at our unusual events rule. We've had this slide before, but just as a reviewer, so we carry it forward. When we're looking at, we've already looked at doing exactly, we looked at calculate the probability of getting exactly that event. If the language is asking for something at least as extreme, then we calculate the probability of getting that event or any others that are that high or that low, depending upon the direction specified in the problem. So when we're looking at this here, if we're going to work this out, our p is now solving for at least 3 correct answers. And so what is it going to look like when we write it out in terms of our probability formula? Pause the video here for a moment and write that out, and then turn the video back on and we'll check it together. Well, you should have gotten p of 3 plus p of 4 plus p of 5. So we're putting these 3 together. Okay? So if it means that all the ways the number of correct answers is 3, 4, and 5, then I need to get the probability of each one of those, and I'm going to add it all together. So we've already got our probability of p of getting exactly 3, 0.051. So the next is to solve for p of 4. So take a few moments, walk through the steps we just went over, and solve for what my p of 4 is going to be in this particular problem. Then turn the video back on and we'll check the answer. Okay, so you would go again down to n equals 5, because remember we've still got 5 questions that we're asking about here, right? The total of 5 possible questions. Now we're looking for x of 4. Right, so now we're solving for the probability of 4. So you're going to go across the right hand side till you reach the column that corresponds with our specified probability of 0.20, and the corresponding number here is 0.006. So I'm going to plug that into my formula. And then now the last one is solving for p of 5. So again, stop the video here for a moment, go through using your distribution table, and get the component corresponding probability for p of 5, and then we'll plug that into this formula and finish up this problem. And again, so you'll be going through your n of 5. Now we're looking for x of 5. And we go across to looking at 0.20, and the corresponding number is 0.000. Into our formula, and we get the probability that the number of correct answers is at least 3 is going to be 0.057. So this concludes our tutorial on using the binomial probability distribution table. Next up, we're going to look at doing binomial problems with using a summary chart.